Creating a platformer game has always been the way to get into game development. Greetings, if you've chosen game development and have chosen Godot, I'm going to help you start creating a 2D platformer from start to finish. In this tutorial series, we are going to be covering 2D player controllers, 2D platformer enemy AI, raycasts, projectile weapons, Tilesheets, and much more. To start off with, create a new 2D scene, rename it to world and add a new node. The new node is going to be called TileMap. A tilemap is basically how you create a new level by drawing in different sprites. For a tilemap, there needs to be a resource called tileset. To create a tileset, you need a tilesheet. I'm going to be using a tilesheet that I downloaded from Kenny's asset website. I'm going to be linking it in the description below. I'm going to be dragging and dropping it into an assets folder in my directory. I'm also adding in a place Spritesheet and an enemy asset for later use. Now that you've added in the tilesheet, you got to load it by pressing the plus button and then choosing your tilesheet. You're going to see an enlarged version of your tilesheet, and what you got to do here is create individual tiles by pressing the new single tile option. After you press the new single tile button, on the top left you're going to see the grid select button. The grid select button is going to draw columns for you, which you can then just click on to select individual tiles. By clicking on an individual tile, you're going to have to click on the new single tile button again to save it into your tile resource. Once you've selected each and every individual tile that you wish to add into your game, you're going to have to add in collisions for your floor tiles. To add in collisions, click on the collision button at the top, and then using the box select at the top left, you're going to drag from one end to the other. This will create a collision box around your tile. This is pretty much how you create a tile resource. Once you're finished marking each and every tile that you wish to add into your game, it's time to get back into tile mapping. Now before we get into tile mapping, let's save our scene in a new folder that I'm going to name Scenes. I'm going to save every single scene into the Scenes folder so that it is kept in an orderly manner. Now click on Tile Maps, and in the Tile Maps option called Cell, you're going to have to set the size to 32 by 32. That is the size most standard tile sheets come in, so you're going to have to use that for now. It's going to be different according to which tile sheet that you use. Now it's time for the fun part of level design. You can go ahead and draw however you like to draw it. I'm going to do a quick little level for the purposes of this tutorial. Once you're done with the level, it's time to start creating your character. To create a character, create a new scene, add in the node 2D, change the type of the node 2D into a kinematic body 2D. A kinematic body is what you always use to create a character. Rename the kinematic body into whatever you like to call it. I'm just going to call it player. You're going to have to add in a few children to the player. I'm going to add in a sprite as well as a collision shape. Once you've added in a collision shape, it's time to give your sprite a texture. I'm using a sprite sheet for this texture. A sprite sheet is basically a group of images that you can then cut up across and down to use as single images or single frames for an animation. To do so, on the animations tab at the side, I'm going to write H frames 9 and V frames 5, since it's 9 images across and 5 frames down. Notice that you get a single image that you can use now. Now it's time to give a shape resource to the collision shape. I'm going to be using capsule shape 2D, and you always have to use capsule shape 2D in most occasions because capsule shape is kind of like the universal collision shape that you use for 2D characters. You can resize the capsule shape using the red dots at the top and the right. You should only use the red dots at the top and right and not the scale tool when resizing a collision shape. You can hide the collision shape now so that it won't be a bother, and it's time to create a new script for the player. You have to create a new folder called script and then add in the scripts for the player into that script folder so that it's orderly. Now you can remove everything that comes by default and then start typing in new stuff. One of the new stuff that you get to write is a constant called gravity. A constant is basically a variable that you cannot change later on in the script, other than of course in the original line of code. So the gravity constant is going to be set to 10. These are parameters that I'm going to be tweaking later on in the video, so don't bother. The next constant is called move speed, which I'm going to be setting to 100, which if you cannot tell is the speed for the character. The next constant to jot down is a constant called up, which is basically vector2.up, which is referring to the up axis or -1 on the y-axis. Another constant that you have to add in is called fall speed, which is basically the terminal velocity for your character, which in layman's terms is the speed which your character caps out at if it keeps falling down. I'm going to give it something like 200. Finally, for now, one final constant called gem strength, which I'm going to be setting to 300. I'm going to be creating a new variable called movement, which is going to be a vector2. This movement, if you watch my top-down shooter tutorial, you will know is what helps you move your character around. Now you're going to create a new function called physics process, and in this physics process you're going to type in the controls, but before that you have to map your inputs. So go to project settings, input map, and start writing down right, left, and shoot and jump in the actions bar. Once you're finished typing, it's time to assign a key to each of these controls. To do so, click on the plus button next to each control, select key, and then click the key that you would like to map on the keyboard. I'm going to be using D and right arrow key for the right control, A and left arrow key for the left control, spacebar for jump, and the left mouse button for shoot. Once you're done with the input mapping each of the controls, it's time to start coding. In the physics process, write down if input.isAction pressed right, movement.x equals move speed. Below that, you got to write elif input.isAction pressed left, movement.x negative speed. Elif is basically a statement that you write down when there are two or more if statements to take into consideration. Below that line of code, it's time to write else, and below that, moment.x equals 0, since you don't want your character to move if there is no button being pressed. Now it's time to add in some gravity. To do so, type movement.y plus equals gravity. This adds the gravity constant that we defined earlier to the movement of y every single delta tick. Jot down below that line of code if movement of y is greater than fall speed, you're going to set movement of y into fall speed. You set the movement of y into fall speed, the constant that we defined earlier, so that your character does not accelerate into low Earth orbit. Now it's time to write the final piece of code for your basic 2D platformer player controller. And that is of course movement equals move and slide, movement up. Move and slide, as I mentioned in my earlier video on top-down zombie shooters, is a built-in function in Godot that helps you to move your kinematic body character around. So let's test it out. However, before that we're going to have to append in the player character, so press on the chain button at the top left and select your player scene. Now click on the play button and I'm going to be defining a main scene, which is the world scene, and once it loads up we are going to be seeing that the player character is moving. However, it is a bit slow for my liking, so we are going to be tweaking the parameters a bit. So over on the player script, I'm going to be changing the constant move speed from 100 to 200. And below the gravity code, I'm going to be typing if is on floor, then if input is action just pressed, jump. Movement.y equals negative jump strength. So what we have added in here, if you could not understand from the input is action just press jump, we have added in a jump function. So when we press the jump button, we must see that the player is jumping. However, I feel like the gravity for the character is a bit too slow, it's a bit too less, so I'm going to be changing the gravity from 10 to 20. And I don't know if you noticed that or not, but the collision shape is a bit off. So I'm going to be raising the collision shape a little bit so that the player character can actually touch the ground. So with a bit more tweaking, I set the jump strength to 500 and the gravity to 27. And back in the player scene, I'm going to be adding in a camera 2D. Now when you add in a camera 2D, make sure that you've checked the current to on. And also enable smoothing and set the speed to however much you would like it to be. Now it's time to start working on the visual stuff for the character. Or on the offset tab, you're going to find an option called Flip Hedge. If you click on it, you're going to see that your character gets mirrored. This is going to be the option that you're going to use to set the orientation of your character sprite, so create a new variable called look right and set it to true. Once you have set the variable to true, over on the input is action pressed right, set the variable to true. And below that, if input is action pressed left, set the look right variable to false. You must have probably gotten what I'm going at right now, so below if it's on floor, write down if look right equals true, then $sprite.flipHedge equals false. Now there are a few stuff that you have to make sure is right. First off, there must be two equal symbols before the true. This is because you're telling the computer to check if look right is set to true, you're not telling it to set it to true. And below, when writing $sprite, the $sign is important because you're using that symbol to reference to the sprite in the node tree. Now below that, write down elif look right equals false, again telling it to check if it is false, then sprite.flipHedge equals true. Now when you run the game, you must notice that the player character sprite is actually mirroring when you move the other way. Now it's time to add in the animations for the player character. To do so, add in an animation player. Once you've added in the animation player, select the sprite from the node tree and click on the big animation button and select new. I'm going to create a new idle animation. So once you've created the new animation, over on the frames in animation, I'm going to select the 15th frame on my sprite sheet, which represents the idle animation, and I'm going to click the key button next to it. This is basically keyframe animation. Now I'm going to create a new animation for the running. For the running, I'm going to be choosing frames 24 through 26 on my sprite sheet. This is going to be different on each and every sprite sheet, so you're going to have to check which is your frame. Now go through each and every frame and click on the key button to add in a keyframe, and that's how you do keyframe animation using the Godot's built-in animation player. Next up, I'm going to be creating a new animation called shoot. This is going to be an animation that's going to be used in a later part of this tutorial series, but I'm just going to create it right now. The frame I'm using is 32nd one. And now that you have the basic animations set up, you're going to have to reference these through code and call them in whenever necessary. So at the top, you're going to create a new variable called onReadyVar_anim, which is going to be a reference to the animation player. You have to write down onReady because this is practically preloading in a sense. So back down in if input.isAction pressed right, you're going to write down anim.play_run. You're going to do the same line of code below if input is action pressed left. However, below else, you're going to add in a different line of code, anim.play_idle. So once you load up the game, you're going to see that the animations are running wonderfully. However, with this single running animation, I'm not quite satisfied, so I'm going to be changing it up with a better animation. And I feel like this is much better of an animation when compared to the earlier one. I'm going to be speeding up the playback speed of the animation player to 1.3. With the exact same process that I mentioned earlier, you're going to have to create two new animations, one for the jump and one for the fall. With the fall and the jump animations being completed, now let's move on to the coding part of things. Below if is on floor, write down if negative is on floor or if it is not on floor, if movement.y is smaller than 0 or if it is going upwards, anim.play_jump. Below that, elif movement.y is larger than 0 or if it is going down, anim.play_fall. Now if you try playing the game, you'll notice that the animations are not playing. Now I added this in intentionally so as to show what happens when code overrides itself. To fix this problem, all you've got to do is move that entire if is not on floor part below the if input is action pressed right or left part. So what actually is going on in here? The problem is that the if not is on floor function is being overridden by the line of code else movement.x equals 0, which sets the animation to idle. Since there is no movement on the x-axis, it's going to set the animation into idle, or it's actually going to choose either the right or the left animations. Now that we have moved the code of line from the top to the bottom, you can see that the animations are working fluidly. Now we're done with the visual part of the player's character. The only thing left to add is an acceleration. So create a new constant called accel. This is going to be set to a low value, something kind of like 10. And down in the part where you set movement.x equals move speed, you're going to set movement.x plus equals accel. Below that, you're going to rewrite movement.x minus equals accel. So you're basically writing the gravity code, but just on the horizontal axis. However, just like the gravity, we don't want the player to launch into near Earth orbit. So what do? We use a function called clamp. So movement.x equals clamp movement.x negative move speed. And down in the else movement.x equals 0, you're going to make a few changes. You're going to set the movement.x equals lerp movement.x 0 and 0.2. A lerp is a function that stands for linear interpolation. In layman's terms, basically all it does is create an acceleration or a deceleration effect. And that's it. You have created a 2D platformer character controller. However, I would like to address a single issue before I wrap this video up, and that is the sliding off of the platform. The player character seems to slide off of the edge of a platform just because of the collision shape that we have used. In case you don't remember, we used a capsule shape, and a capsule is smooth around the edges. To combat this, all you got to do is create a new collision shape, set it to a rectangle shape, and then encase your character sprite well so that it covers the capsule shape as well. And that covers pretty much everything there is for today's episode in this tutorial series of creating a platformer game from scratch in Godot. I hope you learned something from this episode. If you did, don't forget to like, share and subscribe and ring that notification bell so that you'll get notified when the next one comes up. So until then, goodbye.